In this lesson, we will learn how to use ratios to solve simple rate questions. Now, as you will see in the word problems module, there are several strategies for tackling rate questions. However, for simple rate questions, such as the one shown here, we can use ratios to solve. Let's see how. In this question, we are told that Carl is driving at a speed of 45 miles per hour, and we want to calculate how many hours it will take him to drive 120 miles. Now, in a previous lesson, we learned that if we can rephrase any given information in the form for every something there is or are something else, we can use ratios to solve the question. Well, we can take the information in this question and rephrase it as, for every 45 miles driven, 1 hour elapses. This is just another way to say that Carl traveled at a rate of 45 miles per hour. But when we rephrase it this way, we can see that we can use ratios to solve the question. Now, in this ratio, we are comparing the number of miles driven to the number of hours that elapse. The question tells us that this ratio is 45 miles for every 1 hour. Now we want to determine the number of hours it will take to drive 120 miles. So let's replace the number of miles driven with 120, and since we do not yet know the number of hours, let's let t represent the number of hours. Now this ratio, we are told, is equal to 45 to 1. At this point, we have an equation we can solve for t. First, we can cross multiply, then simplify the right-hand side, and then divide both sides by 45. From here, we can simplify this fraction to get 8/3. Since t represents the number of hours, we can say that it will take Carl 8/3 hours to drive 120 miles. Or we can convert 8/3 to a mixed number and say that it will take Carl 2 2/3 hours to drive 120 miles. Alright, let's try another one. Here we are told that a hummingbird's heart beats 70 times in 3.5 seconds, and we want to determine how many times its heart will beat in 1 minute. Well, since we can reword the information to read, for every 70 heartbeats, 3.5 seconds elapse, we can use ratios to solve the question. Here we are comparing the number of times the heart beats to the number of seconds that elapse. We are told that this ratio is 70 beats for every 3.5 seconds. Now the question asks us to find the number of beats in 1 minute, but our ratio is comparing the number of beats to the number of seconds. So to use this given ratio, we must use seconds as our unit of measurement. In other words, we need to convert 1 minute into seconds. Well, since there are 60 seconds in 1 minute, we can replace the number of seconds with 60. Now we don't yet know the number of beats in 60 seconds, so let's let b represent the number of beats. Now this ratio, we are told, is equal to the ratio 70 to 3.5, which means we now have an equation we can solve for b. First, we can cross multiply, and then we can divide both sides by 3.5. From here, we can first simplify 70 over 3.5 to get 20 over 1, and then we can evaluate the right-hand side to get b equals 1200. Since b represents the number of beats, we know that the bird's heart beats 1200 times in 60 seconds. Another way to say this is that it beats 1200 times in 1 minute. Okay, here's another question to consider. Here we are told that a meteor travels 720 kilometers per hour, and we want to determine its speed in kilometers per second. Well, since we can reword the information to read, for every 720 kilometers traveled, 1 hour elapses, we can use ratios to solve the question. Here we are comparing the number of kilometers traveled to the number of hours that elapse. And we are told that this ratio is 720,000 kilometers for every 1 hour. Now the question asks us to find the speed in kilometers per second, but our ratio is comparing kilometers to hours. So to use the given ratio, we must use hours as the unit of measurement. In other words, we need to convert 1 second into hours. Well, we know that there are 3,600 seconds in 1 hour. So if we divide both sides of this equation by 3,600, we see that 1 second is equal to 1/3600th of an hour. At this point, we can replace the number of hours with 1/3600th of an hour, which is the same as 1 second. Now we don't know the number of kilometers traveled in 1 second, so let's let k represent the number of kilometers traveled. This ratio, we are told, is equal to 720,000 to 1, which means we now have an equation we can solve for k. First, we can cross multiply, and then when we evaluate the right-hand side, we get k equals 200. Since k represents the number of kilometers traveled, we now know that the meteor travels 200 kilometers in 1 second. In other words, the meteor travels at a speed of 200 kilometers per second. Now please note that to solve this question, we converted 1 second into 1/3600th of an hour. We could have also solved the question by converting 1 hour into 3600 seconds. Here's how. Notice that when we originally solved the question, we set up the ratio to compare kilometers to hours. Now let's see what happens when we set up the ratio comparing kilometers to seconds. Now we already know that for every 720,000 kilometers traveled, 1 hour elapses. So since 1 hour is equal to 3600 seconds, we can reword our statement to say, for every 720,000 kilometers traveled, 3600 seconds elapse. At this point, we can return to our ratio and say that the number of kilometers to the number of seconds is equal to 720,000 kilometers to 3600 seconds. Now our goal is to find the number of kilometers traveled in 1 second, so let's replace the number of seconds with 1. Since we don't know the number of kilometers traveled in 1 second, let's let k represent the number of kilometers traveled. Now this ratio, we are told, is equal to 720,000 to 3600. So we now have an equation we can solve for k. First, we can simplify the right-hand side by dividing top and bottom by 100 to get 7200 over 36, which is equal to 200. Since k represents the number of kilometers traveled, we know that the meteor travels 200 kilometers in 1 second. In other words, the meteor travels at a speed of 200 kilometers per second. So by converting hours to seconds, we still reach the same answer here. Okay, let's summarize. In this lesson, we learned how to use ratios to solve simple rate questions.